Hello to viewers, welcome to my channel Science to Technology. In today's breakdown episode of the Expo Ganzkuhl, so we're going to talk about what the hell is this Ganzkuhl. So I hope you have seen the Expo recording and this is a breakdown of what the heck is going on. So we are talking about PDRC, aka passive daytime radiative cooling. Now be mindful, everything that exists generally has the ability to dump energy as photons. That's why infrared thermometer works. So that's a normal. Radiative, everything radiates. Cooling meaning you possess the ability to go below ambient. Let's say ambient is 50 degrees Celsius, you can go to 48 degrees Celsius. That will be classified as cooling. So using photons as an energy carrier medium and the ability to go below ambient. Passive meaning you are not consuming electricity or any sort of chemical fuel, and daytime meaning you can do this to the sun's face. You can look sun directly in the eye and you will still be cool. So it's the ultra cool kind of scenario. So what is the requirement for this sort of technology? Surface that reflects almost 100% of sunlight, meaning sunlight can easily dump 1000 watts of energy per meter square. So sun is hot and sun's powerful and is pumping a lot of energy. So we need to reflect almost 100% of it. Now let that be very clear. 100% is the aspirational goal. Under the known laws of physics, it would be very difficult to have absolute 100%. You can have like 99.9999, but absolute 100% is like, ooh. So, and again, when you're talking a sun is a broad wave spectrum. So lasers can be reflected with very high efficiency. Broad spectrum like sun is like, ooh, that's difficult. So you have to figure out a way to reject almost all of sun's heat. Sun is like, here's a kilowatt of heat. You're like, nope. You just have to nope it. So that's the first requirement. On top of that, everything also has an emission signature. Basically, how does it emit light? So its own thermal photons. So it has to emit in IR window, meaning Earth atmosphere has a atmosphere. That atmosphere is made out of gases. Each gases has a different property, so to say. Basically, some gases are like, this wavelength is my wavelength. I'm going to react to it. I'm going to vibe to it. Some gases will not vibe to it. So there are mixtures in our atmosphere. For example, nitrogen, oxygen, water vapor, and stuff like that. So it creates a blanket. That blanket is what we call greenhouse effect. However, in that blanket there is a hole. That hole is a window, meaning atmosphere does not exist for you. For example, why the heck Earth does not freeze at night? Because all the photon that the Earth emits back, majority of it is being caught by the atmosphere and going nope. And why Earth is heating up? Basically, that ratio of that photon that is being bounced back is going up. So instead of like, let's just say back in the old days, let's say 50% of photons were going to vacuum of space. Now only 48% are going. That 2% extra gain is cooking us alive. So we have to find a way to dump heat as in photon in wavelength that atmosphere is blind to. Basically, if you have that wavelength emission, atmosphere does not exist. It's like basically no gases in the atmosphere generally will react to it. It's like it's transparent to it. So that window is between 8 to 14 micrometer, aka infrared, what we classify as long wave infrared, LWIR. That sweet spot is the window. You can just dump as much heat as you want and it will not make it hotter. Meaning, imagine if you had an air conditioning unit that was dumping heat into that wavelength. Yeah, it will not make the surroundings hotter because the heat will go into the universe. And can we heat up the universe? Sun has been trying for a few million years and the answer is no. So you don't have to worry about it. Photons does not bounce back from the air. That's the key part. Photon shall not send it back. Like basically you launch the photon into deep space, it will never come back. That's the whole target. And this allows, because you are dumping heat, and first you are not receiving heat from the sun, second you are dumping it, over time you will start to go down below ambient. Basically you are making a heat pipe that is connecting Earth's surface to the deep space. And the connecting medium is photons. So you will start to leach heat away. And because you are leaching heat away, your temperature will drop. And lo and behold, you can easily go below ambient and few degrees below ambient. Like some people have achieved like almost 7 degrees Celsius below ambient. So sun is like, yeah, 40 degrees Celsius. And this is like, bruh, 32, man. Chill, man. Chill. No, and passive, no electrical consumption. It's just like chill. It's like literally staring down the sun while chilling itself. So Oh, and be mindful, it keeps working at night also. Only difference is at night it's far more effective, meaning in daytime you are looking at 5 watts to 15 watts of cooling per meter square, but nighttime it could go higher. So it's a cheat code. But again, everything about this is known, tested, we have known this. It's just that doing it in daytime, that's the hard part. Everything else is known and sorted. It's just that doing that in nighttime, daytime, while looking at the sun, that's the brutal part. So 150 watt per meter square is theoretically assumed to be the maximum, but we're never gonna achieve that, because making a reflector that reflects almost 100%, it's not possible. Again, sun is very broadband, and construction, manufacturing, noise in the environment makes it difficult. So most of the energy is already consumed by the sun itself. Basically, you reflect 99%. That 1% is still 100 watt. That 100 watt of heat has to be rejected by the cooling part. So now your cooling has gone down from 150 cooling to only 50. And that's assuming you only have 99% efficiency. So majority of the cooling power is being eaten up by the leakage. That's why the real world paint who have made it, they are only getting 3 to 5 to 15 watts of cooling per meter square. Now that may sound small, but you have to understand that's huge, especially for large flat objects like warehouses or even houses. Sun is the primary source of energy. If you reject it and you are dumping heat at the same time, that's shut up, take money. That's like you're literally cooling yourself down. The only reason this will not allow you to go down at very low temperature is not because it can't do that. It's just that atmosphere starts to dump heat away, meaning first your house will start to cool down. Then all the ambient air is like, whoa, 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 there's a ice block next to me. It will start dumping heat. So to actually achieve that, where it's like everything cools down, everything around you has to be coated in something like this. So let that be very clear. That may sound like 5 watt or 15 watt per meter square. It's not that much. It's a lot, specifically if sun is not able to dump that heat. So that is PDRC. Sun dumps heat, you reject it. You emit your own heat, which atmosphere cannot bounce back, and ta-da, you get cooling. Now Ganzkuhl, basically this individual, again, I am hoping you have seen the expo video. He used special sauce, ceramic sauce. I did ask what is the sauce made out of. It is special sauce. So it's tailor-made for cooling in Indian weather. Let that be very clear. There are a lot of companies with a lot of ideas. Some have like, what if we grow nanofilm? What if we use microsphere? What if we use this? What if we use that? He figured out based on what India has, how is the Indian environment, what is the Indian humidity condition. Based on that data point, he made something that works for Indian scenario. And you know, we are kind of close to the equator, so our sun is extra lovely to us. It's like extra heat. He can reflect 98.6% of heat can be rejected. That's good. So basically, sun dumps heat is like boing, you just boinks it. And it can radiate in the infrared wavelength that is transparent. So, and there was requirement because again his co-founder is also an architect. There was a requirement that it should not be a mirror finish. There are certain coatings that people have developed. It does work, but it's a freaking mirror, meaning you can't walk on it, and not to mention it's a hazard, glare hazard for aircrafts and all that, and not to mention you can't walk on it, you will blind yourself. So the requirement was that it should be human safe, as in if you coat everything on it, still should be walkable, it still should be like, you know, hey, I can look into it and not go blind. So he did figure out matte finish, as in it looked like just white paint, not a mirror finish. And this is where it gets special sauce actually becomes special. Everything so far doable, very rugged. What does that rugged mean? Meaning it can survive you walking on it. You can walk on it and it will not damage it. There are many microsphere systems, but they collapse. They are nanocrystal, touch them, it becomes useless. This is rugged. And waterproofing coating also, because again, the way ceramic is and the bonding structure is being created, not only you are getting something that you can walk on, but you are also getting something that is like water shall not pass. That's shut up, take money. So, and it will be sold to you in cans. It's almost like a paint. It is a paint. So you get your roof, you clean that puppy up, then you pressure wash it, and then you apply primer, and then you put coats of it. 2 or 3 coats should be fine. So that's Ganzkuhl. And I get direct, he also coated the car. Car is coated in that, and car was cooler. And be mindful, cooling a car is far more difficult than anything else, simply because it's a freaking greenhouse on wheels. So that much radiation can go inside because of the glass and will be trapped inside. But if you can reduce basically the surface, the steel surface temperature, it still affects it. So he did that, and it's amazing. So what are the pros and cons of this? Well, it is a bit spicy. It's a 50 rupees per square meter, which, mind you, this is the price I got it from him from 2026. Inflation, future, I do not know when you are watching this video, so price may change. But what does it mean at this point in time? Contextually, it's not cheap, but it's not too expensive. Like, people have done things more expensive than this for household, waterproofing and all that. So it's not unreasonable. And not to mention, it's not stupid. It's not like iPhone. It's not stupid. So ROI is there, meaning if you live in India, you are burning a lot of money in just running your air condition. And if you can cool down your room even by 5 degrees Celsius without doing anything, that will directly translate into you having less wear and tear your air condition and less power consumption. And if it's more than like 10 degree, that's like GG. So, by the way, they have done it on just sheet metal roofs, like structures, factory structures were like, it was not designed for human comfort. It was just like, okay, just put a metal sheet. They coated it and dropped the temperature 12 degrees Celsius. So that is flat out very quick ROI for Indian customers. Again, that's why I specified Indian market, hot places. Australia, that will also work. Middle East, it will also work. But not that, basically, if you are more concerned about ice and winter, not really for you, but for us folks, it's necessary. Although lifespan is not extreme, even though it's rugged and ceramic and all that, they are only certifying it for 3 to 5 years. That part was underwhelming. Now, be mindful, I'm not mad at it, given the fact that nobody has figured out how to make it that it can last. And other companies just made it into a panel. It's like, don't walk on the panel. He made a paint that actually can work and survive. 3 to 5 years is like, that's where we need to do more R&D. Everything else is sorted. And company needs to scale up. While the company is real, it's here, and people are buying the product and starting to apply it, it does need to scale up a lot, so it can enjoy the benefit of what we classify as economy of scale. So prices can come down. And again, I did suggest them, let's see whether they do it or not, that they should also make panels. The reason for that is, if you have panels, not just painting, the panels, something radiative panels like this, advantage is your building is still not getting hot, because again, the panel is a perfect barrier there. And the cooling power here, you can couple that cooling power with your air conditioning unit. The idea is air conditioner compressor goes and then increases the temperature as hot as it can make. Let's just say 70 degrees Celsius. Air temperature is 50 degrees Celsius. It will do its best to condense that liquid, but it won't be able to condense too much. But after it has gone through condenser, it has tried to dump as much heat as it can. After that, this puppy is like, I got you. It allows you to dump more heat. Now, instead of your AC pooping itself at like peak noon, it's like, bro, I got this. It's not perfect, but it's like, I got this. And the fact that it will work 24/7, as in like the radiative panel, as long as there is no cloud or fog, which, mind you, if you have clouds and fog, temperature would be a bit lower anyway. This will be able to, like, when sun is going staring contest, this is like, I got you, fam. Not only your building will not heat up, because again, sunlight is not falling on it, and the cooling can be utilized most effectively, directly reducing your cost. And again, be mindful, cooling cost is so brutal, even 10% reduction is lots of money. So I did ask them, it's like, they should really look into the cooling panel design, because that solves one of the problem. While it will be more expensive, it will be a complete product. You just buy it, attach the water lines, done, go home. So there are certain pros and cons of it. Now, are there alternatives? Well, let's begin. This is a very cool technology, meaning every Tom, Dick and Harry who has brain is working on it. And I mean everybody, and I mean every continent. Yes, all of them are working on it. So from corporate to YouTubers, every Tom, Dick and Harry is working on it. And if you can crack it, it's what we classify as shut up, take money. Again, I'm not joking. I'm genuinely serious about investing money into this in order to get it coated in my rooftop, because again, while 2025 was kind, we had too much rain and all that random rain, so temperature was not brutal. 2024 was almost lethal, and I want to make sure that my upper floor does not get cook off. So again, I am genuinely serious about trying to get into touch and actually get my roof coated. So it is in a category as shut up, take money. And for example, take India, this gentleman, he made the same thing again. You can go through the full recipe, how the heck you buy the material, how the heck you build it. He did that with barium sulfate. You'll find that word again and again. A lot of people have used barium sulfate to make that. And Nighthawk did even a cheaper version, which is calcium carbonate variant, a microsphere. And you can do that in house. Now let that be very clear. While both of them successfully made something that does work, absolutely works, everything is fine and dandy, yeah, none of them are robust. None of them are robust, meaning this one I would prefer as a practical option, given the fact that it was so low cost that you can actually do it and have a cellophane paper on top that is protecting it and yearly replace it. This one is like, and again, none of them can give you, okay, walk on it. Now you're like, okay, why walking on it matters? The idea is he also had contracted a temple. Temple had a place where people walk barefoot and it's hot. What if it's coated in something that makes it cool during daytime while people are walking on it? It did that, so people are happy about that. That's why that walkability is a very crucial thing. It's not just like it's like a good add-on. No, it's a crucial thing. Having water resistance, that's might sound a small thing for people who do not know rain. For Indians, it's like we have rain for 2 months continuously. So yeah, any sort of water barrier, we good. So and again, while the special ceramic is not working like microsphere, it has some different sort of nano system. Microsphere is the most common topology you will see. The idea is there are things that can easily do what we want it to do. Block sunlight and reject in the IR window. That's easy. But how the heck you have that much material in the pigment? So you need what we call solid loading. You need almost 100% solid loading, because failure to do so, photons from sun will just penetrate it. The moment that happens, cooling would be defeated. So you need packing density. Spheres are very good at packing density, but they only can occupy 66% of volume. So you pack balls, and after that you find a smaller ball, like 1/3 of the size. Then those balls get packed into the empty space, fill up the 66%. You get even micro balls. Those you flood into that area. So you do this 3 times and tada, now you have almost 100% solid loading, meaning even photon can't go through it. It's like, nope. So that's why you will keep hearing microsphere, microsphere, microsphere. That's the reason. Nano coatings are other option, but I have not seen anyone who's like, just paint it. All the nano coatings are like, this is a special process. It's almost like growing a solar cell. So tedious and complicated. So there are alternatives, and let them figure. And we want it. Everybody needs it. Australians need it. Indian needs it. Middle East people need it. Every Tom, Dick and Harry needs it. We need it. And there lies the core part. This is one of the few expos I have been to. I have been to a lot, ironically, where I'm like, yeah, I need to buy this. So it is, the earth is eating up a lot, and AC just makes it worse. That's the ironic part about it. It's like, okay, let's say these places which are crossing 60 degrees Celsius, it's hot. Meaning air condition is quitting, like flat out. Residential air conditioners are like, bro, I'm not designed to work at that. I can't give you 25 degrees Celsius indoor temperature if the outside is 60. And that's happening. By the way, this is Indian map from ISRO, thermal map and all that. Yeah, it is hot. It's getting hotter. So it's brutal. And what does AC does? Leaches heat from the inside, dumps it outside, which makes outside even hotter, which again, because you have insulation around, it's not perfect. Energy still leaks in. Now your AC has to work even harder, consuming more electricity, which heats up everything even more. So it's a self-fulfilling death spiral. And we are close to death, meaning you can easily have a scenario 5 to 15 years from now where like Indians dying. Why? Because just air temperature reached too high. Like we have a certain level of ruggedness where it's like, okay, we stand the heat. Yeah, you can't. If your lungs, like if air going inside your lung is about 60 degrees Celsius, your body is like, bro, you being roasted alive. I'm not designed for that. Like not men enough. Yeah, we are not built for Arrakis. This sort of temperature is not sustainable. Right now, it's only reaching the peak time. But given the brutality of heat island effect, yeah, that will become a normal temperature, meaning you have to either evacuate all the basically metropolitan area, which is not viable, or you have to shut off schools, and basically people cannot be exposed to the outside. And only thing that can work in that is chillers, which means it will drink water like there is no tomorrow. So fundamentally, let that be very clear. Anything that is starting to exceed 50 degrees Celsius air temperature, it's brutal for human. It's almost at the upper limit of human tolerance. If it goes above that and stays there, like, from 11 a.m. to let's say 5 p.m., it's 70 degrees or 60 degrees Celsius. Yeah, we did. It's not, we did. So we need it. Let that be very clear. I want PDRC to be here, to be real, to be cheap, to be available by multiple contractors, multiple companies, every Tom, Dick and Harry. This is not a luxury. It's not a desire. It's a compulsory requirement. We have to. Otherwise, like big cities are already too close. Not even joking. Like I did not know why the heck they had to make the color white. It's like, yeah, it would not make sense if everything is raw, red. How the heck you make sure that people understand that's cooked? Yeah, white. That's cooked. So heat island effects need to be tamed now, not in the future, now. So at least I'm happy that somebody is actually making it and I have the luxury of connecting with them. But again, we need this. And again, I want every Tom, Dick and Harry, every paint company to work their ass off onto it. It's like, we need this. Oh, be mindful, the same story applies in the most places like China, even in USA, certain places. Again, not for the places that are closer to the freezing Canada, but places that are closer to Mexico. So it's a real problematic thing that we have to solve. Thankfully, technology is there. We just have to solve. Now, let that be clear. People will like, what happens in the winter? Here's the deal. For this, winter is not that real. And not to mention, heat can be created 100% efficiently. Fun fact, you can get heat with 200% efficiency easily. It's called heat pump. Run your AC in reverse. It's solved problem. You can wear winter coats. You can't do anything if air temperature is 60 degrees Celsius. Nothing works. So winter is far smaller problem than heat is. So, and again, this way dumping heat into the vacuum of space, basically be mindful, sun has been glowing for millions of years. The vacuum of space still does not care. Same thing will happen, meaning we can dump heat without causing a feedback loop for our worst future. So this is something awesome. This is something necessary. And I wish all the best to Ganzkuhl to become successful. And again, I want other companies also to crack this puppy. I want multiple option, cost to be very cheap. And again, government, sooner or later, they have to find a law where it's like, yeah, if you are in a metropolitan area, you just have to have white, the end. There is no color option allowed. We will be cooked alive if we do. So just... So this was my presentation on basically Ganzkuhl. I hope you have liked it, learned from it. In that case, please hit the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show my disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.